Imagine two clocks. One rests here on our familiar home planet, the sphere of Earth we all know and love. The other embarks on a journey of mind-boggling speed and distance. It boards a meticulously designed, technologically advanced spaceship, designed to travel at velocities rivaling the speed of light, the maximum speed limit of the universe. Both of these clocks, as different as their journeys may be, started off identical, crafted with precision in the same batch, accurate to the tiniest fraction of a second. Yet, as each embark on their respective journeys, they begin to experience time in a vastly different manner. The subtle yet profound differences they encounter is not something from the realm of magic or fantasy, not something born out of a wild daydream or a vivid imagination. No, these differences stem from the very laws of physics themselves. This is not a tale birthed a magician's hat, but in a scientist's lab. It is a tale of science, a tale of relativity to be precise, Einstein's potent expression of the workings of the universe. As our spaceship-equipped clock begins its journey, it starts to accelerate, slowly at first, and then more rapidly. It reaches speeds that would make even light seem sluggish, speeds that are nearly impossible us to comprehend. As it does so, a peculiar phenomenon begins to occur. The clock that once ticked away in harmony with its twin back on Earth begins to tick slower, much slower. The once synchronized ticking now seems like a distant memory as the spaceship clock's second hand starts to lag behind. To the clock itself, and to any hypothetical passenger on board the spaceship, everything feels normal. Time appears to progress as it always has. The seconds, minutes, and hours still seem to maintain their customary pace. But to an observer on Earth, watching through a powerful telescope, the spaceship clock's second hand seems to crawl, each tick laboriously itself forward, stretching out as though time itself is being pulled and protracted like taffy. The ticks, once sharp and punctual, now seem to dawdle, sluggishly marking the passage of time. This strange, almost surreal behavior of time, where it can stretch and contract, where it can be manipulated and altered based on speed and gravity, is not an anomaly, not a glitch in the matrix, but a fundamental aspect of the universe we inhabit. It's an integral part of the cosmic fabric, woven into the very threads of reality. Time, as we understand it, is not a fixed constant but a dynamic entity, susceptible to alteration under certain circumstances. Confused? Well, you are not alone. This is the mind-bending concept of time dilation, a concept that has perplexed the greatest minds, a concept that challenges our understanding of the universe, a concept that is as fascinating as it is bewildering. It forces us to reevaluate our understanding of time, to reconsider its immutable flow. It presents us with the startling reality that time, as absolute as it may seem, is in fact relative, dependent on the vagaries of speed and gravity. This concept, born in the crucible of Einstein's genius, continues to astonish and confound us. It is a testament to the beautiful complexities of the universe, a testament to the unending quest for knowledge, a testament to the breathtaking scope of scientific discovery. The concept of time dilation is a journey into the unknown, a sojourn into the world of relativity. It is a journey that challenges us, surprises us, and ultimately enlightens us. It is a journey that reminds us of the immense potential of human curiosity, the power of scientific discovery, and mysteries of the universe waiting to be unraveled. The concept of time dilation is not just a scientific theory, but a symbol of our eternal quest for understanding, our unquenchable thirst for knowledge. Imagine two clocks. Let's embark on an intellectual journey. Consider a pair of twins. One continues to experience life on Earth, while the other packs his bags for a thrilling space journey, hurtling through the cosmos at speeds nearing that of light. This intricate narrative scenario is one we designate the twin paradox. This compelling hypothesis serves as a thought experiment that stretches our understanding of a perplexing concept known as time dilation. In this fascinating scenario, the adventurous twin sets off on a mission, boarding a state-of-the-art spaceship and thrusting forward, gradually accelerating to a speed that is almost that of light. This is where the magic of Albert Einstein's profound theory of relativity enters the picture. Einstein's groundbreaking theory proposes that as objects move closer to the speed of light, or experience intense gravitational pull, time for them begins to crawl at a slower pace relative to an observer stationed in a weaker gravitational field. Imagine the scenario. The twin on the spaceship is journeying around the universe, the clock on his spaceship marking time at a slower pace compared to the clock back on our home planet Earth. The concept is mind-boggling, isn't it? But let's continue. This is where things get even more mesmerizing. Now let's fast forward a few years. After countless adventures and experiences, the spacefaring twin completes his journey and returns to Earth. He steps off the spaceship to reunite with his stay-at-home sibling. The reunion is joyous, yet something is intriguingly different. The twist in the tale is that the twin who traversed the vast expanse of space, who dared to leave the comforts of Earth and journey into the unknown, would be younger than the one who chose to remain on Earth. Yes, that's correct. Space-traveling twin is now younger, not older. An unexpected twist, isn't it? But why is this the case? The answer lies in the extraordinary phenomenon of time dilation. The time experienced by the adventurous traveling twin was expanded or dilated compared to the time experienced by the stay-at-home twin. This effect is so pronounced that if the traveling twin spent a significant amount of time hurtling near the speed of light, he could return to find his earthbound sibling aged considerably more. This may sound like a plot straight out of a science fiction novel, but it is a well-documented reality. It's factual. This phenomenon isn't just theoretical, it has been experimentally confirmed. Consider the example of GPS satellites. They have to adjust for time dilation effects daily to keep their onboard clocks in sync with those on Earth. This phenomenal reality showcases the wonders of science and the intricacies of time and space. Now let's return to our twins, who started their lives together, grew up side by side, but due to the quirks of relativity and dilation, their life paths diverged in a way that seems almost mystical to us. The traveling twin was in essence journeying into the future relative to his earthbound sibling. As we ponder this paradox, it becomes clear just how astonishing the universe truly is. In this way, the traveling twin has journeyed into the future compared to his earthbound sibling. It's a journey beyond the confines of our current understanding, exploring the boundaries of time and space, and truly an adventure into the future. You might think time dilation is a purely theoretical concept, something out of a science fiction novel. But surprisingly, it's more real than you might imagine. In fact, it's a vital part of our everyday lives. Let's take the Global Positioning System, or GPS, as an example. The GPS satellites are moving at high speeds and are further away from the Earth's gravity compared to us. According to Einstein's theory of relativity, these two factors cause time to tick slightly slower for these satellites than for us here on Earth. If we didn't account for this time dilation, the GPS system would give inaccurate location data. Imagine being led astray by your GPS, not because of a programming error, but due to a fundamental principle of the universe. This is why engineers have to correct for time dilation when designing GPS satellites. So, time dilation, as strange as it seems, is a part of our everyday life. So, what does this all mean? What are the implications of time dilation? Well, let's delve a little deeper. Time dilation challenges our everyday understanding of time, a notion we often take for granted as a fixed and unchanging entity. But in the world of physics, it's a different story. Time, it turns out, is a flexible dimension, bending and stretching under the influence of speed and gravity. This means that time can flow at different rates for different observers, based on their relative velocities or gravitational environments. It's a mind-bending concept, isn't it? This phenomenon could have profound implications for future space travel, potentially allowing astronauts to venture further into the cosmos than we ever thought possible. And closer to home, it forces us to reconsider the nature of reality itself. Time dilation, a concept that challenges our perception of reality, proves that time is indeed a flexible dimension, as fascinating as it is perplexing.